Okay, so now we're going to go over the powers of I. So powers means we're doing exponents. Okay, so quick overview of exponents. Remember that a positive exponent, so let's say x to the second power would be written like that. And well, it doesn't really equal it to anything, right? It's just our x to the second power. Now, if it's negative though, if it's negative, then we can rewrite it as 1 over x to the positive 2. Okay, so that's just in case. So you might see this, I to the negative 3, then you rewrite it as I, and then y to the I to the positive 3, like that. So, and yes, we do want to make it positive. We don't want to leave it as a negative, so we'd have to do this. Also, vice versa, if you were to see it in the denominator as a negative, then you would pull it out of the denominator and you would actually write it above as a positive, like that. So technically you wouldn't need the division, this line. Oops, trying to erase this, there you go. So you wouldn't need that line, it would just be I to the positive 3. So this negative means basically to switch it, right? So move it up to the top, this one move it down to the bottom, okay? So hopefully that's a quick reminder of what that negative means. All right, so now let's talk about powers of I. So the I to the first power is just I. We don't need to put the exponent, but that was equal to the square root of negative 1, just so remember that. I to the second power, okay, that's going to be the square root of negative 1 times the square root of negative 1. And then again, remember, anytime you have the square root of something times the square root of something, it is that something. So it's 5. So in this case, it's negative 1. I to the third power can be broken down as I to the second power times I to the first power, right? Because 2 and 1 is 3. We add exponents. So that is a negative 1 times I. So it is just negative I. So this is equal to negative I. I to the fourth power, that is equal to I squared times I squared. So that's negative 1 times negative 1. So the answer is 1. If I were to do I to the fifth power and I to the sixth power and so on, I would see that there's a pattern. So I to the fifth is I to the fourth times I to the first. Well, I to the fourth was 1. I to the first was I, so I get I. So I should start getting suspicious and think, you know what, there might be some kind of a loop here, right? So if I got this, I'm going back to the top, maybe I to the second power or I to the sixth would be the same thing as I to the second power, right? So that one is I to the fourth, right, times I to the second. So that is 1 times I to the second. So yeah, it's I to the second, right? It's simplified to I to the second only by itself. So there is a pattern. It does repeat. Okay? So to recap, I to the first power is just I. I to the second power is negative 1. I to the third power, that is, we said was negative I. And then I to the fourth power is equal to 1. So yes, you do need to notice on that one I kind of got stuck. Yeah, because it's not natural for you to remember these kind of things, right? It's not that easy. So it is useful to write it down, and then you can use it as you work them out. So let's say I have I to the something easy, seventh power. Well, I could just continue counting. So I to the first, I to the second, third, fourth, 5, 6, 7, right here. So it's negative I. Okay? Now something special happens or something easy happens that whenever we're doing patterns like this, you have 4 choices, 1, 2, 3, 4. So if you were to divide by 4, right, so the answer, you divide it by once in and then the remainder, and you look at your remainder. That remainder is going to tell you which one of these you're going to choose. You see? So if I were to do another question and then say I to the 21st power. Well, I'm going to, on the side, I'm just going to divide 21 divided by 4 real quick. It's a 5, 20. The remainder is 1. So that means since my remainder is 1, oops, that's not a highlighter. Since the remainder is 1, then I'm going to go with the first one, right? That's my answer. I. This was a 1. Okay, another example. Let's say it's something bigger, a bigger number. And it doesn't matter really how big they get because you're going to be doing the same process. 83. So 83 divided by 4, that's 20. It gives me 80. The remainder is 3. So remainder is 3. That's negative I again. That's my answer. So what happens if it's a whole number and it divides it evenly? So this is remainder 1, remainder 2, remainder 3. Well, remainder 4 is not possible because you're dividing by 4. That means you could be, if it was a remainder 4, that means you didn't divide it by a big enough number. You need to go in one more time. So what if it's I to the 16th, right? So 16 divided by 4, there is no remainder. It's a remainder of 0. So when it's a remainder of 0, that's actually this one. So in that case, the answer is equal to 1. Okay? Equal to 1. So all we're doing is dividing by 4, looking at that remainder, what's left. That remainder will tell you which one you choose. So this is a remainder of 1, remainder of 2, remainder of 3. This one is a remainder of 0 because it goes in exactly the correct amount of time. There's nothing left over. So then that would be equal to 1.